Welcome back, pre-algebra class, to yet another episode of Mr. Chow Time. Today we are solving systems of equations algebraically rather than with graphing, which is what we did in the previous lesson. So just as a reminder, a system of equations is a collection of two or more equations with the same set of variables. So when you have one situation, and you've identified a variable that can mean some part of an unknown part of the situation, then and you have two or more of those variables and two or more of those equations, then that's a system of equations. But here in this lesson, we're only going to be dealing with two variables and two equations. So substitution is something that we've already done before in this year, but I'm just going to show you again. So for example, if a plus b equals c, and you know that b equals some other letter, let's say a, then instead of writing this b right here, we can actually say a plus a equals c. And that's what substitution is where you take something that you already know equals something else, and you just put that other thing in there. So for example, let's say we have this system of equations. We have y equals x plus 2, and then we have y equals 5. Well, if we know that y equals 5, we can just put 5 into y here and rewrite this equation as 5 equals x plus 2. Then we just subtract 2 from both sides, and 3 equals x. So now we know what x equals and what y equals. So this would be 3, 5. Remember that when you write the solution to a system of equations, a system that only has one solution, then you would write it in the form of an ordered pair. Okay, your turn. Welcome back. Okay. Here we have y equals 5, so we rewrite this as 5 equals x plus 4. Subtract 4 from both sides, 1 equals x. So the answer is 1, 5. Okay. One more, your turn. Have your way with this. Hi there. Okay. So here we have x equals negative 3 instead of y equals something. So we're just going to put this again into there. Negative 3 equals y plus 4. Then we're going to subtract 4 on both sides and get negative 7 equals y. So this is going to be negative 3, negative 7. There you have it. All right. Sometimes the equations are written in standard form and you have to isolate the variable yourself. Remember, standard form means ax plus by equals c, where you have x and y on one side of the equation, and then your numbers or your constants on the other side, which is what this looks like, right? The numbers, the constant rather, is on this side of the equation, and the variables are on the other side. Well, this we'd have to change. One of them we have to change, and this one is the easier one to change, right? Because this one has just a y by itself instead of a y with a coefficient. Whereas you see this one and this one and this one, all of these have coefficients, which you would have to divide by something. So we can add both sides by 3x and get y equals 3x minus 13. Now that we have this, we can substitute this into the other equation, 4x plus 5. And instead of saying y, we can write in parentheses 3x minus 13. Remember to use the parentheses because y is a single entity, right? It's like it's just one thing. So you have to write this in parentheses because this is also one thing. You want to make sure that it's put together or put into a grouping. Equals 11. Also, you want to be sure that if you isolate the variable on one equation, this one, then you put the isolated variable y into the other equation. You want to put this 3x minus 13 into this y, not this y. Okay? All right, so now we can distribute this 5 into what is y here and get 15x minus 65 equals 11. Now we can combine like terms, right? 4x and 15x equals 19x minus 65 equals 11. Then we're just going to come up here for a little bit more space. 19x minus 65 equals 11. Then we're going to add 65 on both sides to get 19x equals 76. Then we're going to move this over again. We're going to divide both sides by 19 to get what x equals. And let's see, I'm just going to get my calculator out for this. 76 divided by 19 is 4. So x equals 4. Now we can take this and substitute it back into either of these equations. I'm going to use this one again because the y doesn't have a coefficient. It's a little bit easier for me. So we've already changed this one into this, right? So we can use this one as well. So I'm sorry, this one is over here. So y equals 3 times 4 minus 13. So that's 12 minus 13. So y equals negative 1. So it's 4, negative 1. Here's your final answer after substituting. Okay. Your turn. All right, I'm going to do this one here. So I'm going to subtract 4x from both sides. So this is negative 4x plus 1 equals y. I like to write the x first. You could write 1 minus 4x, but for me it's just easier to do it this way. This is what I prefer to do. Okay, so I would substitute this into this one here. So 3, I don't know why I did that, 2x minus 3 times negative 4x plus 1 equals negative 10. So this is 2x minus, plus 12x minus 3 equals negative 10. Combine like terms here. That's 14x minus 3. That's a 4. I hate that my pen does that. Equals negative 10 plus 3 on both sides. 14x equals negative 7. X equals negative 1 over 2. Okay, so I'm going to substitute that into this equation here because it's easy to multiply negative 1/2 by 2. So 2x minus 3y equals negative 10. We're going to substitute x, which is negative 1/2, into this. And then subtract 3y equals negative 10. So this is negative 1, right? Negative 1 minus 3y equals negative 10 plus 1 on both sides. Negative 3y equals negative 9 divided by negative 3. Y equals 3. So our answer is negative 1/2 and 3. Great. Okay, here is another your turn. I'm going to solve for this one first because I know that I want to divide by 2 into the 4 and the 6 because I have to divide here, right? All of the coefficients here are not 1, which means you have to divide by something. And if I'm going to divide, I would rather divide 4 and 6 by 2. So let's start there. 2x minus 4y equals 6. So I'm going to add 4y to both sides. So 2x equals 4y plus 6. I'm going to divide both sides by 2. And x equals 2y. 4y divided by 2 is 2y. And then 6 divided by 2 is 3. Now I can put this into the other equation here. So 3 times 2y plus 3 minus 5y equals 3. And then I'm going to distribute here again. 3 times 2y is 6y. 3 times 3 is 9 minus 5y equals 3. I'm going to combine our like terms. 6y and negative 5y is just y, plus 9 equals 3. Then I'm going to subtract both sides by 9, and y equals negative 6. Then I'll take this and I'll plug it into one of these two equations. I'm going to use this one this time, just to use them both. Why not? 3x minus 5y equals 3. Then I will plug in negative 6 into y here. So this is now negative 5 times negative 6. We'll just bring down the 3x and the equals 3. Then we'll just multiply these two together to get positive 30 equals 3. Minus 30, 3x equals negative 27. Divide by 3, x equals negative 9. So our answer is negative 6, negative 9. And if you want to check your answer, what you would do is you would just put these numbers into both of these equations and make sure that you can solve them. And if you can, then you've done it correctly. Okay. Remember from the last lesson that not all systems of equations have solutions. Sometimes if they're parallel lines, meaning that they have the same slope, they will not ever intersect. Sometimes they are just the same line and they do have solutions, but they have an infinite number of solutions. It's not going to look like an ordered pair. So for example, let's solve this. So here y equals 5 or x plus 5, right? So we'll just plug that into here to get 2 times x plus 5 minus 2x equals 10. Then we'll distribute, and that is 2x plus 5 minus 2x equals 10. And we'll see the 2x and the negative 2x are like terms, and they'll cancel each other out. 5 equals 10. 5 does not equal 10. So you know that this is no solution. All right. Your turn. Solve the system algebraically. So again, we're going to put the y equals 2x minus or plus 4, negative 2x plus 4. We're going to put it into here. So 4x plus 2 times negative 2x plus 4 equals 8. Then we'll distribute this 2x and negative 2x is negative 4x, and then 2 times 4 is 8 equals 8. These cancel out, these like terms, so it's 8 equals 8. If it's true, then this is infinitely many solutions. All right, your turn. Here we can see that x minus y is negative 4 and x minus y is then negative 1, which means negative 4 equals negative 1. We can see that this is already not true, but let's just solve it anyway just so you can see what I mean. So x minus y, I'm going to show you a little trick here that the book is not teaching you. We can actually substitute x minus y for another letter, like a. And if we do that, we can see that here, instead of x minus y, we're going to say a equals negative 4. And here, we're going to have a equals 1. And a cannot be both -4 and 1 at the same time. So this is no solutions. Otherwise, you can solve this algebraically and you'll get the same thing. Okay. Interpreting solutions. A system of equations, just like all math, is used to represent real-world problems. And in these real-world problems, you'll get some solution and you'll need to know what that solution means. It's not just going to be like -4 and -2, which is just an ordered pair, right? It doesn't have any meaning. And so in the context of the problem, in whatever the situation is, what do the numbers mean? That is an important part of solving some of the more difficult problems on the test. So let's say that Sophie is buying some cars for her new car dealership, and she has a budget of $500,000 USD. So she has a US car dealership, she has $500,000, and she wants to buy some cars to sell. And so she agrees to buy Toyotas for $15,000 per Toyota. For each car, it's going to be $15,000. And she agrees to buy Fords for $5,000. And she's going to need a total of 50 cars to start her business. How many of each type of car can she buy? Well, we could just guess and check, right? We could just say oh, she can buy 5 Fords and 5 Toyotas and see how much that is and see if she has money left and then start adding things. But that's not the best way to do it, right? We're going to write a system of equations here. So we can start by defining our variables. So our variables can be f for the number of Fords that she buys, and I'll put buys here, and then t for number of Toyotas. So the number of Fords plus the number of Toyotas is going to equal 50. That's the number of cars that she wants to buy. And each Toyota is $15,000, right? So $15,000 times t plus each Ford is $5,000. $5,000 times f. So for $15,000 for number of Toyotas that she buys plus $5,000 for the number of Fords that she buys, we want that to be $500,000. So what is this going to end up being? Well, this is a system of equations, right? So what I can do is I can rewrite f plus t equals 50. I could subtract t from both sides and get f equals negative t plus 50. And I can substitute that into this equation. 15,000 t plus 5,000 negative t plus 50 equals $500,000. These are some big numbers. I want to use a calculator so I don't make a mistake because, as you might remember, I am prone to mistakes. So let's distribute this first. 15,000 t plus, minus 5,000 t plus 25, and then this many zeros equals 500,000. Make sure when you're doing your math, if you have lots of zeros, to count how many zeros you have and make sure you've done everything correctly. So we're going to subtract $250,000 from both sides. Thankfully, the math is still easy. So we have 15,000 t minus 5,000 t. I probably should have combined those like terms first. Equals 250,000. So 15,000 minus 5,000 is 10,000. T equals 250,000. Yeah. Then I'm going to divide both sides of the equation by 10,000. I'm going to cross out some zeros and we get t equals 25. I didn't even need any calculators. Look at that. Now with t equals 25, I can plug that into this equation because that's easier, right? So that will be f plus 25 equals 50. Subtract 25 from both sides, and f equals 25. Now, look at that, 25, 25. F and t. So what does that mean? Interpret the solution. That means that with $500,000, she can buy 25 Fords and 25 Toyotas and not have any money left over, and she'll have 50 cars. So that'll satisfy all of her requirements. Okay. Your turn. The length of a rectangular garden. A rectangular garden, just for those of you who have forgotten, a garden is just like a place where you can grow vegetables, and rectangular is this shape, right? So the length of a rectangular garden is 4 times its width. The garden has a perimeter of 280 feet. Write an equation, solve the equation, interpret the solution. Okay, welcome back. The length of the garden is 4 times its width, and the width is just the width, right? Perimeter is the distance all the way around the side, right? So that would be 4w plus 4w plus w plus w equals 280. I've skipped a step here. Actually, it's length plus width equals 280. And then length equals 4w. This is actually your system of equations. And then you're going to do what I did here. I did the next step already on accident. So I've substituted, this is actually 2 length times 2 width. Oh my goodness. Not doing so good here. 2 times the length plus 2 times the width equals 280. Length equals 4w. Okay. So I can put this 4w now into this length and get this 4w plus 4w plus w plus w. So this is going to be 10w equals 280. I can divide both sides by 10. W equals 28. Now with this, I can substitute into here. So length equals 4 times 28. That's 80. 80 plus 32 is 112. If I've done that incorrectly, I'm sure someone will let me know. So 28 by 112. So what does that mean? That means the garden is going to be 28 feet in width and 112 feet in length. Okay, your turn, and I'll talk to you in class about our system of equations project. Thanks.